Good morning. Thanks for your patience starting this morning. We just thought we'd give everyone a few minutes to get in, and I imagine we'll have a few people joining us as we go along this morning. I'd just like to take a moment at the start of this meeting to acknowledge the traditional owners of the land on which we sit today. I'd like to pay my respects to their elders past and present. So first of all, I'd like to do some housekeeping. Everyone's going to be on mute in the recording, and we have the ability to ask questions through the question and answer function. And we've got a few people looking at those today, and we'll have Candice come in and ask us the questions. But today you've got presenting myself, Jenny Gannon. I'm the Manager of Generation and Customer Standards at Energy Queensland, and Tim, I'll let you introduce yourself.
Morning, everyone. My name's Tim Luzzi, Manager Intelligent Grid Enablement. I guess my role in these dynamic connections is really kind of the back of house, all the systems that need to come into play to make these envelopes happen.
Wonderful, thanks, Tim. So I'll fire away into the presentation today if I can find my way. So we're here today to talk about dynamic DER. And I suppose the first question is, why is it that we want to do dynamic DER at Ergon and Energex? Well, first of all, we're looking to enable our customers. We've got a few customers that are hitting constraint limits in our network, and they're wanting to access, whether that be feed-in tariffs or the ability to control batteries and things like that. And we see that increasing right across the board to residential customers and commercial and industrial customers. So we're really looking to get the network ready and our customers ready so they're ready to access energy markets as they become available. We're looking to ensure security of supply. Minimum demand is obviously a very big issue in South Australia at the moment, and it's becoming an emerging issue in Queensland. So we're looking to make sure that where we need to put some controls in place to prevent moving to a scenario where we do have a minimum demand event, we can put that kind of system in place, and also, have that security, know we're using our network to the most, but in a safe and secure way. And we'd like to future-proof. There's going to be a lot of DER coming on in the future. We do have quite a lot already. 40% of our customers with detached dwellings have solar at their house. But we want to get ready for electric vehicles, get ready for batteries, and really make the most out of our network by enabling as many people to connect as possible and use the network in the way they need to. So what does the path to dynamic connections look like at Energy Queensland? Well, right now we're in the passive DER stage, where most of our generation is the solar, and we don't have any visibility or interaction with those types of devices. Right now, we're looking to launch Dynamic Operation Enabled. This has got a little bit of a pathway in it, and our paper that we're consulting on talks about what we're planning to do in certain stages. But basically, we're looking to open the door at the moment, get the standards in place, the contracts in place, and in 6 to 12 months, we'll be releasing a register for people to register on, and we'll be able to advertise dynamic limits to them. But this is a no regrets path for us. People who are interested in accessing dynamic connections can put that to us now, get the contracts in place, put the right equipment in place, and be ready to access that registration system when it's ready. And then from there, we're looking to move and enable those two-way markets over the next couple of years, bring in technology that Tim was talking about around a DERM system and state estimation, and move to where DER is fully optimized on our low voltage and medium voltage networks. We're looking obviously to enable DER connections, but what does that actually mean to us? Well, we've had to put a lot of systems work in place. So there's been some trials that we've done, particularly on the LV networks or the MV networks for commercial industrial size customers. We've gone out to market for a 2030.5 utility server, and Tim's going to have a chat to us about what that looks like. We've got LV connectivity work going on, looking at our LV networks and how and making sure we've got all our data correct to help support this modelling in the future. And we're looking at putting LV monitoring in, and we're building those back-end DERMs. We've gone out to an expression of interest to look at that very first look at a DERM system. As far as standards go, we've started some consultation with you all last year, and we've been involved in deep through ARENA, looking at that utility server, at the SEP2 integration guide, or implementation guide, What we're doing now is to release these interim draft standards. We'll be looking at refining those standards over time with industry until we get to a business as usual solution, and then eventually probably national standardization in this area. That's certainly where we want to aim. As far as connections go, we've been thinking about this for a long time. So when we developed our connection policy, we had this in mind. But now we're at the stage we need to develop some draft contracts, put those contracts in place for these early adopters, and think about how we design our customer portals and some model standing offers in the future. So our model standing offer size customers, which is the bulk of the DR connections that we have, can all be enabled very quickly, and dynamic can be the future. We also have to, for our connections, we have to talk to a lot of different people at a lot of different levels in the stage of the energy cycle, from manufacturers through to electricians and even customers. So we'll be putting together some education packages and getting information out as we move through. As far as the DOE, the dynamic operating envelopes, we've spent many years working on state estimation. We've done a number of trials, including an ARENA trial, and we're still in that development stage. We'll be putting a lot more effort into how that technology works. We're working with external companies for that, and we'll be moving through to bringing state estimation into the company and having optimization of the dynamic DER operation. Moving on here. So what does it look like today? Basically, we're introducing 3 new standards in the dynamic space, one for the very small customers, one for LV customers, and one for our isolated communities. We're also at the moment consulting about our 4777 Part 2 revisions for our existing standards for small, low voltage and high voltage, and all of those changes that we've brought into those current standards are being rolled in as well to those dynamic standards. So it's a perfect time to bring it all in together. We've also been able to restructure, particularly our 1170 small customer standard, to put the sections that are negotiated into the relevant areas and make that primarily focused on the model standing off of customers only, which aligns us better with the ENA technical guideline process and what some of the other states have been doing. We also have the discussion paper available at the moment, and this really is setting the pathway for us. So yes, okay, on the 18th of December, we're going to be bringing out some new standards. We're going to be revising some standards, but it's really about this long-term path. So the discussion paper is just another point of conversation. We want to check in with you, see that the direction that we're going suits industry and really fits in the timeframes on what people can deliver. And so we're really keen for you to answer those questions, and we'll have some information about how you can do that later on in the session. Just quickly, we have updated our standards for 4777 Part 2. If you don't want to read all of those drafts, I can fully understand. So I've given you a bit of a summary on what it is that we've changed in there. Basically, they're effective from the 18th of December in line with legislation. We've chosen in Queensland to go with Region A settings. This is a great initiative that's taken a few years of industry working together to come up with national settings, and all of those set points. You go in, you select Region A, and the installer doesn't really need to do much else other than possibly setting an export limit if that's the circumstance they have for that installation. But it's a great initiative, and it's really going to drive up compliance. So one of the benefits of that is we've been able to align with AS 477 Part 1 and move our voltage rise calculation back from the point of common coupling to the point of supply. So what do these regions look like, and what do the settings look like? Here's a quick summary. There are a few other settings in Region A, but these are the prime ones that we often talk about. You can see there from the information we got from the ENA that most of the NEM, other than Tasmania, are selecting Region A. This is great for companies that work across jurisdictions, and the settings over there to the right are just as a reference. But primarily we're using volt var, volt watt now, and there's been an introduction of a second under voltage limit in order to support networks from a system security set point. So we came out and had a conversation with you last year and early this year, and we just wanted to reflect on what we heard from everyone and how we've used that and incorporated it into our solutions. So we engaged with a lot of people, and we really thank everyone who did participate in that process and have really contacted us a lot through the year so that we can help formulate this solution. Overall, we had overwhelming support for us to introduce dynamic connections, and the majority of people were happy for us to use IEEE 2030.5, which we're referring to now as SEP 2, using that technology because it was the most suitable for allowing the multitude of connections that we'll need to have at this small scale. There was feedback that people were very keen to see a national solution for the implementation, not wanting to see each jurisdiction or each utility come up with their own implementation guide. So we've really taken that on board. And there was a lot of other feedback about little areas. One of the key things was some variance around timeframes. So some people said they'd be able to deliver a solution straight away. They already had it developed. And there was a number of other, it was kind of split down the middle, a number of other people who thought that they needed a little bit longer. So we've taken advantage of the development going on in the national space with the implementation guide, with the 4777 changes to push this back from our earlier projections back to December so that we can roll this all out together. Oh, this is over to Tim now. I'll just...
Thanks, Jenny. Do you want to give me control of the pack there?
It's not working, so I might just have to have a few minutes.
All right. While you're doing that, I guess as Jenny alluded to there, we've started to refer, and you may have noticed this in the consultation paper, to IEEE 2030.5 as SEP 2. That is the kind of friendly name for the standard, much like Zigbee or Bluetooth or Wi-Fi. And it just makes it a bit easier to kind of refer to in documentation and when we're talking in presentations and so on. So if you see SEP 2 in the consultation paper, it should be there in the definitions that it is referring to 2030.5. All right, thanks, Jenny. I think I have control now.
Sorry about the complication. Is that working?
It hasn't gone full screen for me yet.
That looks good for me.
Can we just switch the swap? That's it. All right, cool. I think we're in control. So you may recall in the last consultation in February this year, I did a kind of high-level overview of what SEP 2 is, just to give you an idea of how it works and demystify it a bit. And I used the example of Homer Simpson checking his Google Calendar, because that is very similar to what how SEP 2 works for inverters. So SEP 2 is built on top of HTTP, which is kind of the protocol that sort of ties the whole internet together, and it works on a client-server kind of relationship, or a request-response relationship, where a client initiates a connection to a server, and inside that initiation, there'll be a set of authentication and identification of who that user is. So Google receive that. They know who it is, whether or not he's authorized to look at that calendar, and they send back that information in his calendar. And that calendar is literally a sequence of events, of things that Homer might be attending, and for how long they are, and various bits of information inside that response. And to sort of round it out, he is able to then, inform the Google server that he's downloaded that, received those events, and likewise can post additional information to the server if the server requires it. So that analogy flows very well with how SEP 2 works with in the kind of machine-to-machine inverter to utility process, in that the DER being the client. I've shown an inverter there, but it could be sort of any sort of smart device, if you like. it sends a request to the utility server, which could be us as utility directly, or it could be an intermediary, aggregator or vendor cloud or something. And it literally asks, so what's on the agenda for today? And within that request, again, the server is able to identify who that client is, where they are on the network based on kind of pre-populated information, and therefore provide them with a sequence of events, which we now know as an operating envelope, and how they should sort of, what sort of bounds that they should operate within for the next sort of foreseeable future, say 24 hours. And those events are literally have a sort of a start time and a duration, and how they and what the kind of limit is for that duration, and there might be a whole sequence of them. And likewise, from the previous example, that client can confirm receipt of those events, can also let the server know when it's sort of successfully completed them, and also post telemetry from its kind of local monitoring back to the server. And that's pretty much it. So SEP 2 is kind of the standardization of those exchanges. It was designed for this purpose kind of in mind from the ground up, and is built on very sort of standard, common communications, internet communications sort of standards, which allow it to make use of an existing stack of kind of security and so on. It's sort of a very well understood combination, and is very well suited to kind of using that public internet framework. The other one that you might see mentioned in the dynamic consultation paper is CSIP. And CSIP is the Common Smart Inverter Profile, which is the kind of legislated implementation guide that's come out of California in the US. California obviously being quite a leader in this space, already require all inverters and all aggregators to comply with the CSIP implementation guide as part of their Rule 21 legislation. So I guess overall, in summary, at a high level, the SEP 2 is a secure communication methodology. It uses public internet. It's suited for high volumes. You know, if you think about the internet and those kind of client-server relationships, in the example of Google, there's well-established technologies to enable hundreds of thousands of requests, even per second, from if we ever sort of get to that scale. And also kind of within the standard, it offers very flexible kind of aggregation models, what we talked about in February. So we can communicate directly from the utility to a device, or kind of the more likely scenario is through a set of intermediaries, aggregators, or vendor clouds, or even kind of a local gateway next to an inverter on site. And the only bit from a utility perspective that we're sort of mandating at this point is the use of SEP 2 for that kind of first hop. I think we talked about potential SEP 2 compliance on the device, and we sort of had strong feedback that would be quite a difficult sort of thing to do. And so at this point, there's no sort of requirement for it to be SEP 2 beyond that kind of first hop. I will note that there seems to be movement in California around mandating that, so that's probably one to watch for all of us. And I think the reason for doing that is probably two things. The first thing is around cybersecurity. I guess once that signal gets pushed to our sort of trusted aggregators, beyond that, we don't have a lot of visibility as to the kind of security frameworks and things that are used in that last kind of leg, which when you think about at scale, that could be a sort of a risk to the network if that aggregator or vendor happens to be hacked or something like that. And then the second thing is around stranded assets. If a vendor or an aggregator moves on, then we might have a large swathe of devices on our network, which are not able to be interfaced with at least very easily. But anyway, that's sort of probably a conversation for the future, and I'm very interested in everyone's feedback on that. So Jenny did mention the last consultation that we ran, and thank you to everyone who did participate in that. We had a lot of really good reading, and I'm sorry we couldn't get back to you all individually. We did sort of collate all the results and have some summaries internally. I suppose overall, as Jenny said, everyone was very supportive of the approach that we're taking in general for dynamic connections. Probably the most mixed response was around the timeframes, which is understandable. These things always take a lot longer than we all think, but we've got to try and push the envelope wherever we can. The one I really wanted to focus on, though, given what I've just talked about, is the protocols. So overall, very strong support for supporting SEP2, at least initially. And I think that's probably largely driven not necessarily by the sort of technical merits of SEP2, but rather the fact that we don't all want to be trying to support multiple protocols across Australia. So it might not necessarily be the best technical solution, but certainly we want some commonality across all the utilities, and we heard that. Just to look at some of the kind of more negative responses around SEP2, because I think it's pretty it's prudent to be kind of devil's advocate here. The least established of the three, which is true. So SEP2 is quite a young kind of protocol. There's probably a fair few rough edges, if you like, which anyone who's sort of dealt with it has experienced, that even if you've got the standard and CSIP in front of you, it does not necessarily guarantee interoperability. Speed of response and size of payload is also another good point. SEP2 at the moment is only a polled protocol in that the client end, the DER, is required to poll the server at a set rate, which can be changed by the server, but there's no sort of generally no capability for the push of near real-time events. If something's changed on the network, it does require that kind of continuous polling. There are some exceptions to that, but for the majority of cases, it probably doesn't apply. And the size of the payload, so SEP2 uses XML, which is sort of known to be quite a sort of heavyweight format. Again, for both of these, I think there's probably a pathway ultimately to having those things sort of fixed, but they're certainly not there at the moment. OpenADR, which is probably one of my more personal favorites, has a pretty robust certification process. Has been used in the sort of demand response realm for a number of years. So that's a very positive thing. And I know of a lot of existing use cases with electric vehicle supply equipment. And then the last one was around vertical integration aspects of SEP2. So SEP2 was developed in the US, where they have a slightly different market to us, and it does include function sets for things like billing and pricing. And I guess the sort of response to that for us is it's just something that we won't use. We'll fundamentally ignore at this point. So. All right, so what's the progress at Energy Queensland since our last consultation? Well, I guess having the response that we did gave us enough confidence that there's something we should invest in and pursue further. And so we've sort of made the formal decision that it's going to be the first protocol that we officially support. We've also deployed a cloud compliance test server. So compliance is still a little bit of a vague area for us, but we've deployed that for probably two reasons. First one is we actually have we are also developing an open source client with a local partner here in Queensland, and we're doing that because we have 5 test sites that we're already been testing on for a number of years, and we want to expand those sites to use 2030.5. And the second reason that we've deployed that to the cloud is the potential to offer some kind of self-certification, but we're sort of asked the question as part of this consultation as to what people think of that. Quality Logic is the test harness that is used in California for CSIP certification. And it's also available off the shelf for vendors and utilities like us to purchase, which is what we have done. I suppose one note on that client that we're developing, we are hoping to open source it on our website to try and encourage, I guess, development in this space, and vendors and companies are welcome to fork that into their products if that suits them. And it has been developed in Node-RED, which is fairly suitable for sort of low spec hardware embedded systems. And then the big one for us is we issued our utility server tender back in August. Got a very good response to, some very strong responses. As these things do, that it's dragged on a bit, but we are very close to finalizing that process, and we aim to kind of go live with that server in sort of the March to June timeframe next year. Initially with our trial sites, and then with some other customer sites, hopefully. So just in terms of that diagram I had up earlier, the RFO just covers that first bit, the utility server. There's a lot of back-end stuff that is also happening concurrently, and you may be interested to know that we have just closed an RFI on a DERM system as well. We sort of led with the utility server, as we think it's very important to kind of get these standards out and enable people to connect, even if we're providing a very basic operating envelope, while we sort of continue to develop our back-end systems to optimize those envelopes. So I guess just for my final slide here, focusing in on probably one of the more interesting tables from a SEP2 perspective in the consultation paper, where we've sort of compared the use of CSIP and CSIP Oz. So CSIP Oz is the kind of local implementation guide. There's a few sort of deficiencies in CSIP that we thought, nationally thought, applied to Australia, and CSIP Oz was created to try and address that. So initially, based on sort of ability to offer some sort of compliance, we will support CSIP, but with the goal to kind of move to CSIP Oz as that sort of path comes clearer for both us and vendors. So just talking a little bit about CSIP quickly. CSIP is a very device-focused, or Redis 23.5 is a very device-focused protocol, where we want to offer envelopes rather at a sort of a site level at the connection point. So we will be using it in a kind of a framework of a device, a site as a device, for those export envelopes. Unfortunately, there isn't a lot of support for import envelopes under CSIP. So we will probably have to wait for CSIP Oz, because that was one of the major things that CSIP Oz addresses for import envelopes at the connection point, and also load control beyond the connection point if that suits. A couple of the other curly things that we're still sort of working through as part of the national working group and internally is around the use of certificate authorities. So I talked about the kind of security layers of CSIP. It uses a very sort of strong security suite of what's known as mutual TLS. And that requires that both the client and the server, it enables them to both trust, they both say they are who they are. So when a client connects, it can be sure that it's talking to Energy Queensland. And likewise, when a client connects, Energy Queensland can be sure that that client is who they say they are. So we don't sort of give the wrong information to the wrong parties, malicious or not. And that requires the use of something called certificate authorities, which is kind of a trusted third party, if you like, for those devices to trust. And under CSIP, they use the SunSpec certificate authority, which is based out of the US. So in order to use CSIP certified devices, we'd need to support the SunSpec certificate authority. But we'd also like to sort of issue our own certificates. And if there's, in the future, if there's an Australian certificate authority that's stood up, we'd like to support that as well. Ultimately, that might be the only one we support, but certainly for a transitionary period, we're hoping that our utility server will be able to support multiple at one time. The other one of note is the potential use of some of the more direct control function sets for specific use cases in SEP2. So where we might have DER under sort of contract for network support, we are looking to use SEP2 to signal those support mechanisms. And then, as I said, ultimately, but the goal is to move to CSIP Oz as the kind of compliance requirements around that implementation guide become a bit clearer. And I think, Jenny, that's it for me. I'll try and hand over back to you. Hopefully that's
Looks
worked.
great. Look at that magic. Wonderful. Well, thanks for that, Tim. So we're just going to summarize how the standards themselves are going to work. Obviously, like Tim said, there's a lot of back-end work that needs to be done to progressively enable these limits to the operating envelopes to be advertised and for all of that integration to work. Lots of protocols that need to be managed by OEMs or aggregators. But from a customer perspective, that we're talking about electricians, talking about RPQs in Queensland, and the standards are just supposed to be simple. It's supposed to tell them, what do you need to move forward? So in Queensland today, this is how we apply our connection standards. We have the little green one there, which is our 1170 standard that covers the small stuff, and that is the bulk of connections that we get in the generator space. So everything under 30 kilowatts with kind of 10 kilowatts per phase. And then in the LV space, our LV standard does cover rotating machines up to 30 kilowatts, but then both inverters and rotating machines up to 1.5 and 1.5 meg, and then there are some situations where aggregation of connection points can lead to larger systems and up to 5 megawatts on the LV. And then that HV standard, again, it covers rotating machines just up to 30, and then above that, right up to very large size. So that HV standard is covering those HV connections. So it's where the customer connects to us at HV, so we can see quite small systems in those networks at times. But what's it going to look like now? Well, we've moved some of our connections from the bulk one. It's still going to be our green 1170 standard there on the screen. That is still going to be the one that the majority of people connect to. What we have done is we've moved anything from that standard that was negotiated and had to actually negotiate a contract with a longer kind of lead time for those out of that standard. Some have gone into the dynamic standard, some have gone over into the HV standard, and there's all of the isolated systems connections are negotiated, so they've gone into an isolated system standard. In the LV space, we've also enabled dynamic operating, and that dynamic connection offers, which will have those dynamic operating envelopes. And the target there is really people that are getting constrained export limits. As mentioned, isolated systems, we don't tend to get a lot of HV connections, and they would be quite specialized. So we've made the standard just for LV, and it's for IES and rotating machines in those communities. And then the HV standard now is just all HV, all IES, all rotating machines, any size if there's a connection at HV. What do dynamic connections look like to us? Well, they're basically setting an export and an import limit within a range. For long term, we're looking at 1.5 kilowatts as being the very minimum. But in the meantime, we do have some extra special options for early adopters so that there's kind of a no penalty type approach to moving towards that, particularly in the under 30 space. There's still fixed limits. So if you lose your communications, you need to move back to those fixed limits, which obviously would be around the 1.5 kilowatts in the future, but for now they can vary between sites. We require that compliance to the SEP2 and CSIP Oz in the long term, but CSIP in the interim, as Tim spoke about. From a communications perspective, we're really just looking for a capability. So a Wi-Fi type connection to the device is fine. It could be hardwired, but we're looking to have that two-way communication and the ability to do that 5-minute interval advertising of dynamic operating envelopes with a forecasting function. And they really need to be registered in order to get access to the dynamic operating. So as we said, that's not going to be available for 6 to 12 months for our customers, but once that is, they'll be able to access those operating envelopes and move between the ranges covered within the standard. So who do we think is going to be one of the people who want to use this as a solution? as soon as possible and might start to sign up with us for dynamic connections now. We've got some single phase customers with capacity constraints. So there's customers out there that are telling us they want to have an 8 kilowatt solar system and a 5 kilowatt battery system. Right now, under our normal standards, the today's solution is, well, sorry, you can't do that. We have a capacity limit on single phase of 10 kilowatts. But in the future, that would be enabled. We're going to allow 10 kilowatts of, up to 10 kilowatts of solar and up to 10 kilowatts of energy storage system under the new proposed dynamic connections. There will be export limits in place for a short period of time until we go into the dynamic solution. So it will be fixed at a 1.5 kilowatt export limit. But a lot of the customers we've had knocking on our door have been telling us they don't even want to export. They just want to get access and be able to use solar and battery together. So we understand it won't be ideal for everyone to start with, but people who are wanting that solution, they'll have that opportunity until the registration system comes up and they get a little bit more flexibility. People who get constrained exports, so certainly our negotiated customers in the over 30 space, we see about 13% of those customers get offered zero export offers, and we see another 20 or so percent get offered a partial export, which can vary from 5% of the size to 95% of the size of the system. So there'll be a range of those customers that see it, the effort of going to dynamic as worth it for them to get greater export capability. The capacity constrained. So we do have some very early innovators that are putting in systems like a solar and a large battery where they've got their own transformer and they're pushing above those transformer limits. They're currently our assets and we don't want to take the risk that the customer may not design their system correctly and we can't really tell what it's doing after 10, 20 years. So we're looking to put this system in place so we have a kind of a backdoor way to know that our assets are going to be treated correctly and that systems continues to perform as per design throughout the life of the system. We have our plain old early adopters. There are some people that see the shiniest, latest thing and want to get involved, and that's fabulous. We want to make this available to them, but there's also companies out there that are going to want to develop their customer offering. So they're going to want to work with a few customers to start with and really make sure that they're at the cutting edge of offering dynamic solutions to their customers. And then in the isolated network space, as we said, there are communities out there that have already met what we call an unmanaged hosting capacity limit, where they need to put a solution in. We've got 5 different sites where these types of solutions exist right now, and we're looking to expand that further as the communications systems get installed there. So what does it look like at the moment? Obviously last year we came out to you and had a bit of a conversation, and that went through till February. In November, just last month, we came out with the drafts and we kicked off this consultation. At the end of this month, we'll have all of those new standards in place, and we'll also be kicking off some QECM consultation because we're doing some changes in that space as well. There's a lot of changes just to support industry, but some of them will be impacting on some of these DR technologies. So keen for you to have a look out about what's going on in that consultation. It'll be up on Talking Energy like this one has been. And if you're interested in knowing particularly about the QECM, please feel free to email us about it. So what are we consulting about here? Obviously, that pathway that we spoke about, where we're planning to go. We'd love to hear your feedback. We want to make sure we can really respond to what industry requires and that what we're delivering is suitable and be able to be supported. We've obviously got the 4777.2 standards out at the moment and keen to hear if we've got that interpretation right. And then our dynamic DER standards. It's a pretty simple implementation, but we do believe that it will change in the future as other people start to work on their standards. And after we've tried to use it with a few customers, we might get some feedback. But for now, we're looking for a no regrets path for customers that want to connect under that. So that's what we're looking for, something that will work. It'll give us the option to go back to that customer and work with them over the next 20 years, because that's possibly how long some of these contracts will be in place. So we just need it to be suitable and no regrets focused. How do you have your say? Obviously, we've got the webinar today, which is wonderful. Great to have you here. The feedback's closing on the 9th of December. So if you can get your feedback in, there's a couple of ways you can get it in. You can go onto the Talking Energy site, the link's there, and there's a quick feedback form, lots of yes and no answers, and that can come through really quickly. If you're willing to put in a little bit more effort and you want to put a bit of a conversation piece, email us at Standards Feedback, send through any documents you want to. We welcome all feedback. I'll go over to questions now, Candice.
So there currently is just one. So it looks like the first one's for you, Tim. Are there any options for higher frequency telemetry, e.g. 1 minute or even 1 second?
So no, we'll only be requesting 5-minute telemetry as per the CSIP Oz guidelines. I think it suggests 5 minutes in there. So we'll be asking for 5-minute averages over the period, with the exception of frequency, which we'll be asking for the maximum and the minimum over the period. I think technically SEP2 can support higher frequency, but it's fairly inefficient certainly in the seconds range.
Excellent. Thanks, Tim. The next question from Sean, will the drafts of all the reference documents be available for review and feedback? So that, Sean, is that Talking Energy page that is currently on your screen at the moment. I'll put a link in the chat for everyone that they can jump on and go to that page.
And I'll just jump in there. There are 2 missing at the moment, 1175 and the isolated networks one. We don't get very many customers applying under those in a rapid succession. So we have a little bit of leeway in the focus areas. 1175 will be very similar to what we've done in 1174 as far as the HV standard versus the LV standard, as far as the types of changes that will be made, other than we're bringing in the negotiated options for the 0 to 30. So that's an additional add-in in the HV standard. In the isolated space, we've already been operating a number of dynamic customers. So we've got a lot of process in place to support those going on anyway. So one of the things we're looking to do is host a special session, possibly next week, with some LV and HV, customers who use those HV and LV standards. And we'll be enabling that through our customer teams. The other thing we're doing is we'll probably have a special session on the isolated networks. We've definitely got a little bit more time to get that standard right, because we don't get a mad rush of applications in that space.
Very good. Thanks, Jenny. The next one from Peter, when can we receive more information on certification process, detailed technical guidelines, and can you just reiterate that effective date for dynamic customer connections?
I'll take the first part of that. So, Peter, as it stands, we are considering CSIP certification, but very happy to receive everyone's feedback on that. I know it's an onerous and expensive process. I know within the Australian API working group, there is conversations around potential alternatives to that. So it's a little bit of a watch this space at the moment, but I'm very happy to receive feedback as part of this consultation that we can feed into that process.
There was about 3 parts in there. Candice, what was the second part?
The second part was technical guidelines.
Yeah, so I guess as part of that kind of certification conversation, we will have what's known in the industry as a utility handbook, which we are developing at the moment, and that will give some of the more finer details for what we require in order to connect to Energy Queensland Utility Server.
Fantastic. And then the last part, Jenny, was the effective date. If you could just reiterate that one, please.
Yeah, so all of the standards will be effective from the 18th of December. Now, if you're looking to apply for a dynamic connection, obviously we've not been doing this before. They're all negotiated, so it's all a little bit manual. So if you are applying for one of these, please just give us a little bit more time than it would normally take for us to process one of these. a bit of understanding would be great as we try and refine and make sure our processes are fully developed and working well for those. And that's with the target of getting this kind of process right and being able to redesign our systems and move to model standing offers in the future, where they'll be back to being super quick processing. But yeah, look, in the meantime, as we iron out some bumps, we'd love that patience. We don't expect a mad rush on the 18th of December of dynamic connection applications, but if there is, we will let you know, and we'll provide a bit of feedback about any delays that might be experienced from having a bit of an overwhelming response. I think the other thing there, Tim, with the question you answered last, do you have any idea what the timeframes on that handbook that you were talking about would be? Because I'm guessing this was a national handbook you're talking about as part of the DEEP project. I think Tim just can't get off mute.
Thanks, Brittany. Yeah, we are aiming to produce that as part of this consultation. So I think between now and 1st of July is the goal.
Excellent. So then, Jenny, leading on to from those questions, what does the pathway look like for early adopters in the unconstrained area? Will they have an increased static limit?
Just the the 30 and under space as an example. What we'll see is that if you applied for a 30 kilowatt system with a 30 kilowatt export limit, we're not going to be able to enable that today. You'll get a dynamic contract, and we'll be setting the export limit at 5 kilowatts per phase as the fixed limit and the fallback limit. In the future, so if we talk 12 months from now, I would expect that if you applied for a 30 kilowatt system with 30 kilowatts export, that fixed limit would be 1.5. So regardless of whether you're registered on the system or not, it would be 1.5. So the plan long-term is people don't have to register on the system. That's their kind of call. It's if they want to sign up with a dynamic connection or an area where a dynamic connection is the only option they can have, that's fine. It's once they register onto the system that they'll get those opportunities. The dynamic operating limits, we were having a bit of an internal conversation about it yesterday, and it's a huge opportunity for people to really make the most of their engagement with the network where it makes sense financially for them to do that. So yeah, we're just trying to go along a no regrets path, offering 30 kilowatts with 30 kilowatts export as a fixed export limit has become untenable on our low voltage networks. It really is more and more when we do an assessment, they're getting knocked back anyway. But we're really seeing that meeting those technical constraint limits from a theoretical perspective. Our assessment criteria works on theory, so it may or may not be suitable for your local area, but we're still looking to offer every individual customer, the small customers, at least 5 kilowatts of export for now. That will move to 1.5 in the future. So if somebody is getting access in a local network to 10 kilowatts per phase, it's really a bit of an unbalanced and an unfair situation. So we've got to think about a holistic solution and a bit of customer advocacy there.
Thanks, Jenny. So touching back onto the telemetry area, so back to Tim, will you want 5-minute telemetry on all the time for every site on a DOE?
Yes, will be part of the agreement, yes.
Excellent. And is it expected for the whole load, or will it support disaggregation? That is like flexible loads like HV, AC, pumps, those kind of things.
Great question, and I'm open to feedback on this one. So certainly for the connection point, in our consultation paper, we did mention at the inverter as well, but I am sort of conscious of some of the implications of that and the extra traffic it will require. I guess from our perspective, having telemetry from the energy generating devices does allow us to do some additional optimization around the dynamic operating envelope. And it also allows us to, I guess, inform us on the amount of curtailment happening, which is ultimately not what we want for anyone.
Excellent. Thanks, Tim. So a clarification being sought. Can we clarify DER? We see DER as including both load and generation. We enable a DOE on the whole of the site, home base, orchestrating the load and the generation behind the meter via a gateway that is 2030, Tim, SEP 2 compliant. Can you please clarify that EnergyQ DER definition includes not only generation, but also load resources?
Yes, absolutely. So I think, as I mentioned there, CSEP Oz makes explicit provision for import envelopes. So that is something we definitely want to support. Is there something you want to add on there, Jenny?
Yeah, look, there's some technologies that right now we're comfortable with the way we have a solution for those, and we're not looking to get rid of our AFLC control of hot water systems and pumps and air conditioning as an offering that we have. These are voluntary options for customers. So we're not looking to roll out SEP 2 as a solution for those technologies right now, but we certainly see technologies like batteries, technologies like electric vehicles with vehicle to grid as things that fall into that category right now. We've mentioned in our paper electric vehicles. We don't think the industry is developed enough in that area, and we really want to have a chat with them over the next 6 months while we're also working on our utility server registration process to see when the EV market, just from a charger perspective, so whether we can have a conversation with chargers or via aggregators to chargers, and they can participate as well in this dynamic operating. At the moment in Queensland, there are some constraints that you can have on the amount of or the size of those devices that you can have on a single phase connection. And so, we're looking to enable the market, particularly in that space. I see that customers, it's going to be their biggest load. And if they are vehicle to grid, it'll be their biggest generator in that space. So we really want to get those solutions working for those types of technologies.
Excellent. And along with what we see in the future, what is the interconnection between the DOE and prices to device, or is that expected to be independent of the DNSP DOE?
Do you want to take that, Jenny? I think
we're fighting over this one.
It's safe to say that there's no connection there. So we sort of see the connection purely being as how big the pipe is into your property, and any sort of layers on top of that is not part of the DOE.
Yeah, look, and I think the other thing I can add, I suppose, is that, from all the modelling I've seen in this space, the benefit that we can get from, a price signal to customers to turn on or off, it's very small part of the time that you could be getting other benefits through different channels. So you're going to make more money with your device through an aggregation service, working with the market and providing particular services. There may be opportunities certainly for those types of incentives to be offered by the DNSP, but the times it would be done are quite small in an aggregate on the year. So I think we'll definitely see those services in the future. Whether they'll be linked to tariffs is a whole different thing.
Excellent. So will we require the DER sites to identify separation of load and generation behind the meter so that there's that knowledge of risk with rapid change in the DER output?
Yeah, I don't think I really understand the last half of that question, but I think overall we're talking to the connection point, right? So we see that as a huge opportunity for the customer, because if they are getting constrained from an export limit, they can supply other things in their premise. And if we think about that single phase customer that can have the 10 PV and the 10 battery or electric vehicle charger with vehicle to grid, what we're seeing there is, that real ability to make your decisions. You're not going to miss out, because if there is a particular constraint on that day, then you can make that decision. We will have forecasted in most cases, and you'll know this is when I'm going to charge from my PV system into my battery, and this is the time I should be exporting and making the most of that access to the network to get a feed-in tariff. So yeah, I think that was a technical question though about drastic change. Is it about hunting or?
So I think it's more just about visibility, Jenny, and that separation about whether we want to see exactly what load and exactly what generation is happening behind the meter. But I think you answered that in your first part where you mentioned we kind of are looking at the connection point as a whole. If not, Tim, please feel free to email me and tell me that we didn't quite answer your question.
Yeah, and look, one of the things I'd like to say, I'll just add in there,
Yep.
we are talking about this pathway. Once we definitely have the registration system in place and we've got a little bit more confidence in the way people are designing system, we do see that even in single phase, it might push up to allowing past 20 kilowatts. And, you know, whether we're concerned in the future about what technology you're using, you know, is certainly, it's all on the table as things we can consider in the future. But for right now, with the technology that we do have available, with the fact that the registration system isn't available today, we've just matched what some of the other states offer, which is the 10 and 10.
Very good. So I'm just super conscious of the time. I will let everyone know that I have noted down all your feedback that you have put in the chat and any questions. So the final question I thought we could answer today is, will the QEMM draft review be also on this Talking Energy link?
Yeah, so the link that we have there is for dynamic connections, but if you see the first part of the consultation, it's www.talkingenergy.com.au. So the QECM will go up onto that main page, and you'll be able to link to it from there. It'd be great if there's anyone in particular that's interested in being included on our stakeholder email list to let us know via the standards feedback line, so that we can make sure we give you as early as notification as we can that that's gone up. We're going to do it in a number of stages. We'll be coming out, first of all, just with a conversation piece, and then we'll be moving into the drafting. One of the key things with the QECM is that we're looking to move away from offering the QEMM and moving to the national standard in that space, which is the MIR. So that will be one of the things we're talking about. So if you have an interest in that space, we'd definitely like to hear from you.
Excellent. And it's 11 o'clock, Jenny, so if you would like to wrap.
Wonderful. Look, thank you for everyone for your great questions and for joining in on this webinar. It will be available hopefully this afternoon up on the Talking Energy page for any of your colleagues that might have missed it. So please send your questions through to standards feedback, and thanks again for your time.